3 in chapter 7? Remember that this chapter is all about patterns. So yesterday we did order of operations, where we learned about the order in which we solve math expressions. So first, anything in the parentheses. Second, the exponents. Third would be the multiplying and dividing parts. And then last would be any addition and subtraction pieces. So today, we're going to kind of switch gears a little bit and talk about how you write an expression. Basically, they're going to give us a word problem. And we have to read through the word problem and try to figure out how we would write an expression for that word problem. Because anytime you have a word problem, like for instance, if they tell you that somebody went to the store and they bought some carrots that were $1.97, they bought some lettuce that was $1.65, then they bought a can of beans, which was 99 cents. How much did they spend? You can do that by adding up those three amounts, and then getting an amount would be how much they paid. Then maybe they'll ask, and then they had a coupon where they got 10% off. So then you might have to subtract 10% from what your total was. So sometimes, just an example. So sometimes you have more than one operation in an expression. And a lot of times our problem of the day, you have more than one thing that you're doing. And so writing an expression helps you to keep all of your information there and in order the right way. So that's what we're going to be doing today, is writing expressions from word problems. So we have to read the word problem, figure out what operation we're going to use, and then figure out how we're going to write that into an expression. And actually, yesterday's homework, you did that a little bit yesterday's homework. So when you read some of the word problems, you had to write what the expression would be. A couple of them they gave to you, but a couple you had to do on your own and figure out what it is exactly you were supposed to be doing. So that's what we're doing today. So here's your problem of the day. It says, one bag at an apple orchard can hold 24 apples. How many bags are needed for 14 dozen apples? Use pictures, words, or numbers to explain your answer. So it's not asking how many bags to hold 14 apples. It says 14 dozen. So first we have to know how many is in a dozen. Anybody know?
12.
How many? 12. There's 12 in a dozen.
You can do this without multiplying.
So we might need to figure out how many apples 14 dozen would be. So we'd have to use multiplication on that one, right? And then we'll have to figure out, using division, how many bags you would need. So we're going to use a couple of different operations here. So I want you to think about it. Use your notes. Write it into your notes or on a whiteboard if you have a whiteboard, okay? So take a minute to think before you ask anybody else or tell anybody else, okay? Think about it on your own. There's out there. Okay, what did you guys get?
20%.
What'd you get?
I got 7.
Seven bags?
7. I did a bunch of work.
All right, let's see. So,
Yeah,
okay, hold on. Let's see if we get the same thing.
I got this.
Maybe the way you did it could work as well. Okay, ready? We have 14 dozen apples. So first we should find out how many single apples we're talking about. So there's a dozen for every dozen. That means 12 single apples. So that's why we're doing 14 times 12. So 2 times 4 is 8. 2 times 1 is 2, and then we put a 0 underneath. 1 times 4 is 4, and 1 times 1 is 1. So then we get 168. So 14 dozen apples is really 168 apples. It's equal to the same thing. And it says that each bag at the orchard can hold 24 apples. So for every 24 is going to equal 1 bag. So I heard Aiden and a couple other people talking about how they got to their answer of 7. He said he was using guess and check. I saw some people using some pictures to try to draw, like, this bag is 24 apples can go in this bag, 24 can go in this. Maybe they used like repeated addition to try to find it. Some people just guessed, made a number, maybe 5 or 6 times 24 to see how close they can get up to 168. So, and then I heard Malachi saying, I'm going to double check my answer. After he did the division, he went and did the multiplication and made sure that it equaled the same thing. So 24 times 7, that would be 14 plus 2 is 168. So 7 bags would hold 168 apples if each bag can hold 24. So the answer would be 7 bags. Nolan, why don't you explain how you got your answer?
What I did was, okay, I know that a dozen is 12, okay? I multiply 12 times 2, which gets me 24, okay? Then I go 2, 4, 6, 8, 12, 14. Wait.
Oh, 14.
No,
2, 6, 4, 8.
No, wait. 2, 4, 6, 8, 10, 12. That's how I got 7. And then you see, because I went by 2, because that's 2 dozen per bag.
Yes. So it's 2 dozen, and so what he's saying is he used, since each bag really technically holds 2 dozen because it says it holds 24, then he was able to count by 2s, knowing that 2 dozen would fit in each
I
bag.
decided not to go into that huge.
Okay. And that's how because he went up to 14 because it's 14 dozen.
This is what I did.
So you have 14 total dozen, and if each bag holds 2 dozen, half of 14 is 7, which is what he did.
This is how I got my
Either way, I think you could get either one.
What the heck?
24 minus 3.
Wait.
minus
That equals 7. But how? I'm not sure how.
This is how I did it.
So if you were writing an equation, so this is what we're doing today. So look at the screen. I'm not going to do all the work again, but I'm going to show you what the equation might look like. Okay, so you could do 14 times 12, because that's how we figured out how many we had, and then I'm going to put a parenthesis around that. And then once we got an answer, we divided it by 24. So this is what the equation would look like for this word problem. So we solved the problem, but we didn't write the equation first. So what we're going to do today is look at the word problems and figure out what the equation would be to help us solve it. So you have to figure out if you're adding, subtracting, multiplying, or dividing, because that's really super important, right? If you're going to solve a word problem, you got to know which operation you're going to use. So once you figure that out, then you have to figure out in what order will I do them. That's why I put the parentheses around the multiplication part, because I knew that had to come first, and then you were going to divide by 24. Yes, Ashley.
I did it different than both you and
Okay, how did you do it?
I did it where what else would I say mine? 12 I knew 12 was 1 dozen, and then I knew that 24 is half of 12. 12 is half of 24.
Right.
And so I knew that would be 2 dozen. Then I knew 14 times 2, divided by 2 would be 7. So that's how I got my answer.
Right. So sounds like you both had a different way of explaining basically the same process that you both did, but it sounded a little different because of the way you explained it. So she explained it as dividing by 2, and you kind of explained it as multiplying by 2, I think, because you guys one of you started here and went there, and the other one started here and went there. Right. Okay. So good job. You guys came up with different ways. That's definitely a way that you could use to solve that one.
Show my characters.
All right. So now I need you to look over into your notes. And we're going to do a couple of examples here from into your notes. So in your notes, I need you to write Chapter 7, Lesson 3. And this is called Evaluate Numerical Expressions. Write numerical expressions, sorry. Write numerical expressions. And then we actually have our first problem is already typed in for us up here. So here's what it says. It says that Susie divides her candy into 3 bags. Then she gives 2 pieces from one of the bags to a friend. Here's what you need to know about what we're doing today. Sometimes we do not know, we're not going to be able to solve. Remember how I just said evaluate numerical expressions? That's not really what we're doing. We're just writing them. So sometimes we're not evaluating them. The word evaluate means to solve. Sometimes we're not giving an answer to the question. All we're doing is finding what the expression might look like. Sometimes we don't have enough information to write the entire thing. Okay? So if we don't have enough information to solve the expression, all we're doing is writing an expression. Okay, so does it tell us how many pieces of candy she has?
No.
So are we able to solve this? We're not able to solve this, right? We can write an expression and we're going to use a letter in place of the information that we don't have. Have you ever done that before?
Algebra.
Okay, good. It's algebra. It's called a variable. So a variable means it's a letter that represents an unknown number. So in this case, we're going to use a variable to explain, to write an expression, but we can't solve this because we don't have the right information. Okay? So if Susie has her candy, we're gonna since we don't know exactly how much candy she has, we're gonna use the letter C for the amount of candy that Susie has. So it'll pop up there. So she's gonna divide her candy into 3 bags. So however much candy she has, we're gonna use the letter C, and she's gonna divide that into 3 bags. Got to do that first. And then one of the bags, so after she divides it, she's going to take one of the bags of candy and she's going to give away 2 pieces. So which operation would that be? Angelina.
That would be 2 pieces.
If she gives something away, would it be adding, subtracting, multiplying, or dividing? Subtracting. So after she divides her candy into 3 bags, we're going to subtract 2 pieces from one of the bags. This is an expression. So the difference between an expression and an equation is that an expression doesn't have an equal sign. Do you see? Think about the word equation, how it has the word, kind of, you can see like the part of the word equal in there. Kind of helps you remember that this is an expression. So we can't find an answer to this question unless it said, and Susie had 150 pieces of candy. Okay, so if Susie had 150 pieces of candy, then we could replace the letter C with 150, divide that by 3, and that would give us 50, right? And then we would subtract 2 away, and we'd have 48 pieces of candy. Okay, but we can't do that because they didn't tell us how many pieces of candy she has. So actually, C divided by 3 minus 2 is the expression. And this part's going to come first. That's the division. That has to come before the subtraction. Plus, the way the word problem was written, it told us that first she divides the candy, and then she gives away 2 pieces from one of the bags. Yes?
Is there a way that you can turn letters into numbers? Yeah.
One of the lessons that we're going to do in this chapter, they're going to tell us they may give us an expression like this and then tell us what would the answer be if C was 150? What would the answer be if C was 90? What would the answer be if C was 120? So then you'll have to put the right.
Would it be extremely hard? Probably not.
Not too hard because you've done it before. So a variable, let's write that in our notes because we're going to use that word.
I was just asking if in college or something.
You'll do it this year and next year and the next. Yeah, it's all algebra. It's all algebra. Whenever we use letters in our math, it's all algebra. Oh yeah, sure. Go ahead. Okay, so a variable is a letter that replaces an unknown number. Write this in your notes.
Oh, okay. Are we going to do this very much today?
This is, what do you mean, notes?
No, I mean in the math assignment.
This is what we're doing, yes. Problems like this is exactly what you're going to be doing in the math assignment today.
Oh, yay. It's going to be fairly easy.
You just have to, now, so if word problems are kind of like not your thing, then you're going to have to really pay close attention today. So, because you're reading words and you're turning the words into a math problem. And so if you have a hard time figuring out whether you're adding or subtracting or dividing or multiplying, you're going to have to really be patient with today's lesson and look really close because that's really what you're doing. If you write the wrong operation, you would obviously get the wrong answer at the end, right? If you add when you're really supposed to subtract, you would get a different answer. So let's try. All you need to make sure you have in your notes is this piece right here about a variable. A variable replaces an unknown number. So you're going to see some word problems today. You'll also see sometimes they're going to just give you a phrase and you have to figure out how to write it in an expression. So let's see if one of those we have up next as an example. I'm going to zoom in because this looks small. Make sure you can see it. Scoot this way. Doesn't want to scoot. Okay, I can't make it bigger because then you won't be able to see it. I'm going to read you the first one. It says, Mrs. Holson removes 5 students from the class of 26. She then divides them into 7 groups. This is going to be in your notes. So I need you to write, I'm not going to make you write all of these, but you do have, otherwise your notes are going to be meaningless. If your notes have none of the word problem piece to it, you're just going to see a bunch of expressions in your notes. It's not really going to help you with anything. So I'd like you to write this first one right here in your notes. Like I said, I'm not going to make you write all of them.
Okay.
So here's what it says. I'll try to zoom in again and see if I can get it to.
You just write the first one.
For right now, I just want you to write the first one. It says, Mrs. Holson removes 7 students from the class of 26. She then divides them into 7 groups. So let's think about, she removes 5 students from the class.
I'm saying you said 7 though instead of 5.
Then she divides them into 7 groups. Sorry if I said the wrong thing. Okay, so let's think of which operations we're going to use first. So if she's removing 5 students from her class of 26, what operation do you think we're going to use first? When I say operation, I mean adding, subtracting, multiplying, dividing. Ava, what do you think? Subtraction. So our first part of the problem is going to show that she started with 26. I'll write it here on the line. Out of 26, she removed 5 from the group. And I'm going to put a parenthesis around that because, remember, parentheses come first. So anything that's inside the parentheses is what I'm going to solve first. So I can't do the dividing by 7 because I'm going to divide them into 7 groups next. I have to do that after the 5 kids were removed from the group, right? Because that's what the word problem says to do. So I'm going to do 26 minus 5. Sorry, I have the parentheses on mine, but it's taking a while on my screen here to catch up. So we have 26 minus 5, and then we're going to divide whatever we get by 7. So the directions on this page said to write a numerical expression to represent each real-world situation. It didn't tell us that we needed to solve. So you could solve this one because you have all the numbers that you need to be able to solve, but you didn't really have to. If you did 26 minus 5, what would you get? What would you get? 21. And then if you divided those 21 students up into 7 groups, how many kids would be in each group?
3.
3, because 21 divided by 7 is 3, right? So actually, we if you want to write an answer in on this one, we can. You'll just have to read the directions because sometimes they're not even really. There it is. Yeah, it was taking a while, sorry. So sometimes they don't even ask you for an answer. Make sure you have this entire thing that's in the black box written into your notes because you want to have at least one good example with all the words and everything. Now let's look at the second one. If you want to write this one in, you can write this one in also to your notes. I want you to at least have the one in the box. Yes, words and all. Because look, if you just wrote this, that's not really going to help you remember how to write the expression. You have to see what the words were too. Do you need to sharpen? Go ahead. Thank you for waiting. Okay, here's what the next one looks like. Yes?
I was gonna say, by the way, you need the parentheses if it's addition and subtraction. No, I mean if it's subtraction slash addition, or and division slash multiplication. If it has both, and you're doing the subtraction or addition one first,
Yes.
you need the parentheses.
Because so if I left the parentheses out, really the problem, what you would need to do would be 5 divided by 7 first, which is going to give you a decimal answer. You don't want to do that. It's going to give you totally the wrong answer because that doesn't follow what the word problem says. So yeah, you're right. You would need the parentheses first. But when you're writing the expressions, just remember that whatever the operation that you're going to do first in the problem is what you would put the parentheses around. Okay, the second one, if you want to write it in your notes, you can. If you don't want to write it, I just want you to write what you think the expression is going to look like, okay? So it says, Vera buys 3 rabbits and adds them to her group of 5 rabbits. Then they multiply to 3 times the number of rabbits. So I want you to write in your notes what you think that expression is going to look like. So first you have to think of which operation are you going to use. there's two parts to this question, right? Not all of them are going to have two. Some might even have more than two parts. You have to look really carefully. This one has two. She first buys some rabbits, then they multiply to 3 times the number. So see if you can figure out what the expression's going to look like. And it doesn't actually say for us to solve it unless you just want to. If you want to write the words so you can have another example in your notes, you can. Some people, I just want you to make sure you have that first one. See if anybody has an idea of what that one's going to look like. Anybody have an idea? Catherine, what do you think?
I think it's gonna look like 3 plus 5 with parentheses around that, and then times
You guys agree? Thumbs up? I agree. So she has 3 rabbits and she adds them to her group of already 5. So she has 3 plus 5. And then they multiply to 3 times the number. So you can solve that if you wanted to. It would be 3 and 5 is 8. 8 times 3 would be 24. So then she has a total of 24. What about letter C? Franco buys 4 baseball cards for each of his 6 friends. Then he buys 7 for himself.
It doesn't even ask any question.
You're just writing the expression. What would the expression look like? This one's harder because they don't, some of the words that they use aren't like, letter B was they multiply to 3 times. That was kind of easy, but think about what you think you might do on this one. Nolan, what do you think?
What you would do is 4 times 6.
Because each of his 6 friends gets 4 each, right? So 4 times 6. And then what?
And then plus 7.
Because he buys 7 for himself.
No need for parentheses here.
True. You don't need parentheses because we did the 4 times 6 first, but this is really if you wanted to do it. Some people like to have that separated out to make it so that you could see really easily what you're doing. So 4 times 6 would happen first. So he buys each of his 6 friends 4 cards each, which would be 24 cards. And then he adds 7 more cards because he's buying 7 that are for himself.
We don't even know what we're looking for. It could even have the rest of it say like, then he wants to divide all his cards by.
True. There could be more to the question. So far what you're doing is just putting an expression of for what the information that you do
And you
have.
just write your indices.
Right. Just from what you do have.
As variables.
Any questions so far? Nope. Okay, good. Let's look at the next slide. Let me get back to 100%. One more. I can always go back to let you see it in a little bit if you want to. Sorry, I didn't know anybody was writing all of them, but let's just, yeah. We'll do this one, and then we'll be ready to go onto your worksheet. This one says, Anita has $36. She earns $24 more. Then she divides her money evenly into 3 accounts. She withdraws $9 from one of her accounts. How much money is left in the account from where she withdraws money? Write a numerical expression to represent and explain your reasoning. This one's hard. I see way more than just 2 operations. So the ones we were just doing had 2 operations. This one's got more than 2. So I'm going to leave it up here and I'm going to give you a little bit more time to think about it. You can always talk it out with someone next to you. We have enough people writing up there, but let's see which operations that we think will be used. Everybody ready?
Yep.
Girls on the side, make sure you're looking at the screen. Before we write the expression, we're going to let them finish writing what they have on the board. Let's first talk about what order, which operations we're going to use in which order. So she has $36 and she earns 24 more. So which operation will we use to show that part? Addition. So we're first going to add. Then she divides her money evenly into 3 accounts. So there's division. Then she withdraws $9 from one of those accounts. So that's subtraction because we already talked about that withdrawal means you're taking away. So as you're trying to go through and solve these problems today, boys, I want you to think about, before you start just trying to write the expression, because it does get, bless you, it does get kind of confusing. You have to really think about which operations are we talking about here. So let's look up and see what they wrote up on the board. They wrote $36. Looks like we all kind of have the same thing. $36 plus $24. They have like this. Because she started with 36, we really should have dollar signs here. And then they took that money, $36, she earns 24 more. That's a dollar sign. Then she divides her money evenly into 3 accounts. And this is where we see some people with the brace. We have some brackets here on this one. Technically, you need the brackets around this one and this one, because that lets you know that then you're going to do that division part next. So you're going to start here with the parentheses, 36 and 24. Then whatever you get there, you're going to divide by 3. And then you're going to subtract the $9 from that account. So this one added the braces around the outside. You don't technically need those ones because you don't have anything else.
I just did it because of it.
But you could if you wanted to. So this one, see, she put then the brackets around the outside to close it all in. And technically, you don't really need that because unless you had another operation after that, which we don't. So let's see what it is. 36 and 24. If I add the 3, 30 and 20 gives me 50. Plus 6 and 4 gives me 10 more. So that means a total of $60. Then we're going to divide that by 3, because that's what's in the bracket, which gives us $20. Then $20 minus $9 would be a total of $11. So that means in that one account that she did the withdrawal from, she would have $11 left. There it is. Finally came up. Sorry. I know, I'm sorry. Sometimes it takes it a second. All right, we all got the same thing up on the board, so that was good. Good to see. All right, let's look at your assignment really quick. It says, example number 1. Terrell went to dinner with his friends.
We don't see it.
There it is. It's on your paper anyways. Terrell went to dinner with his friends. He ordered 3 tacos. Each taco costs $2 and has a coupon for $1 off of his total purchase. The total cost in dollars of Terrell's purchase is represented by the phrase, multiply 3 by 2, then subtract 1. Here's what you need to see. Sometimes in today's assignment, you're going to see words like this. Terrell went to dinner with his friends. He ordered 3 tacos. Each taco costs $2 and he has a coupon for $1 off. It may just tell you that. And then it might say, write the expression. Or you could see something like this. Multiply 3 by 2, this part right here, then subtract 1. That's basically what you're doing, right? Because each of his 3 friends, he went to dinner with his friends and ordered 3 tacos. Each one was $2. That would be 3, because 3 tacos times $2 each. So it would look like, we're going to multiply 3 by $2. So it would look like this. And then he had a coupon for $1 off of his total. Okay, so I want you to see that you could see this in 2 different ways on the assignment. Sometimes they're going to have a real world situation, like he and his friends went for tacos, they ordered 3, they were $2 each, and then he had a coupon for $1 off. Or it can say, multiply 3 by 2 and subtract 1. It could just tell you a phrase like that too and ask you to do. But either one of those, you would get this same equation. Okay, so part 2 says then we're going to subtract $1. Does yours have, on the next slide, yes, there's another slide. So let's look at what the next slide says. We're going to write, multiply 3 by 2 would give us $6. So the total cost of the tacos would be $6, 3 tacos at $2 a piece. And then we would subtract $1, which would give us then a total of $5.
Write each part as a numerical expression. Yeah. I think it means like 3 times.
Yes, it does. I wrote that on the other slide, but we'll write it again here. Mine is, it's hard because my slides are always a little different than what your paper is. And then to subtract 1 would look like this. So then we're going to combine the numerical expression. This is what I wrote on the previous slide. 3 times $2 minus $1. It actually doesn't tell us to solve, but if we were going to solve, it would equal $5, right?
Yep.
He'd spend 6 and he gets $1 off. So sometimes you don't even have to solve these. So you have to really read the directions, because sometimes it'll say evaluate the expression. If it tells you to evaluate, the word evaluate really just means to solve. Okay? Let's look at the last example before you can get started. It says a ticket to a baseball game costs $25. The popcorn is $8. 3 friends bought tickets and popcorn. The expression below gives the cost for one friend and for 3 friends. Compare the two expressions without evaluating them. So all we're going to do is look at what the expressions look like and answer some questions about it. We don't even have to write the expression. They did it for us. So for one friend would just be 25, the cost of the ticket, plus $8 for the popcorn, right? That's what the 25 plus 8 comes from. But if you were going to get 3 friends to go and you wanted what the total cost was, you could do 25 plus 8, so 25 for the ticket, 8 for the popcorn, and then you'd multiply whatever you get by 3 because there would be 3 friends. So the questions at the bottom say, both expressions contain the same addition expression. Write the addition expression. The addition part of the problem is 25 plus 8. For 3 friends, the expression is multiplied by 3. Because there would be 3 people getting all of those things. So the second expression is how many times larger than the first? Angelina.
Is 99
It's, did you actually solve it? You solved it and got 99 and 33. It's actually 3 times as large. So on this expression, if you were to solve, one friend would cost $33 and 3 friends would cost $99. So what she was saying was one was 33 and one was 99, but that's 3 times as big because you multiplied it by 3. Okay? So sometimes I just want you to really look because you might do extra work. If it doesn't ask you to solve, you don't need to solve. So if it says to evaluate or to solve, make sure you give an answer though. Okay? Now you're going to see sometimes phrases and sometimes word problems. The number one thing is to think about which operations will I use? Addition, multiplication, subtraction, division, and in which order will I do them? And then try to use your parentheses for that. Okay, work on the guided practice and then make sure that you check it with someone, and then you can start working on the independent practice, and I'm going to give you your 20 minutes time, okay?